Let's upgrade this Ender2. Why not? This is my Ender2, and it's been sitting over there on the shelf for a while now with no 3D printing action whatsoever. I usually don't like to modify 3D printers, because if someone's having an issue with their machine, I can compare it to my machine and try to help them out. With the Ender3 currently filling in the slot for the low-cost, good-quality 3D printer, I thought it'd be a great time to take on a modification project. And what better 3D printer than the Ender2? If you've seen my review on the Ender2, there's a few things that I really didn't like about this machine, although it does get good 3D prints. So there's about a half a dozen different things that I'd like to change on this machine, but the first thing I want to tackle is the Marlin firmware that's loaded on this board. Now the process of upgrading Marlin on the Ender2 is going to be a lot like the CR10. So if you want to see that process, go check it out here. But there are a few things that are going to be specific to the Ender2 that we need to change. So let's get started and get into the config. So I just grabbed a fresh copy of Marlin 1.1.8 from the website, and I'm going to treat it just like we're setting up a CR10. So I'm going to go into Example Configs, Creality, CR10, and just copy all three of these files, and we'll back up a couple levels, and we'll paste them into the main Marlin directory. This is going to overwrite config.h and configuration_adv.h. So we'll paste it, and we'll just tell them to replace the files in the destination. Now we should have the default CR10 config. So let's open up the marlin.inl. So we'll head into configuration.h, and there's only a handful of things that I want to change. We'll go ahead and change the author. It does say CR10. We'll leave it Creality, but we'll just put it as Ender2. The motherboard on my Ender2 is the same Melzi board that they use on the CR10, so no need to change that. We'll change the custom machine name to Ender2, and we'll keep sliding through. And then we get down to the print bed size. So we'll change this from 300 to 300 to 165 by 165. And then Z max position, I'm going to set this to 220. My printer size is actually a little bigger than advertised. I think the advertised is 150, 150, 200. Mine's actually 165, 165, 220. And we'll keep scrolling through. And it looks like the only other thing we need to change is the stock display. So we'll comment out the stock CR10 display, and then we'll scroll back up, and we're going to uncomment the mini panel, because that's the type of display that the Ender2 uses. So we should be good. Let's go ahead and verify. So head to Tools. We need to make sure we have the Sanguino board selected. That's in the CR10 video if you missed it. Make sure you have the right processor selected. We need the 1284 16 megahertz. Make sure you're on the right COM port, and then hit Verify. The Verify looks good. You are going to get a low memory warning, because these boards don't have a lot of room on them. This one's currently at 94%, and we haven't enabled a lot of the options yet. But with any luck, later in this video, we'll address that issue. So let's go ahead and upload. Let's go to Tools. Again, make sure you're on the right board and you have the right processor. Pick your COM port, we'll be on COM 12, and hit Upload. With any luck, your screen should boot up looking like this. So the firmware config's out of the way. That gives us a little more elbow room to move around in the config and change things if we need to. Now the second issue I want to address is the part cooling fan, or lack thereof. Now there's no sense in reinventing the wheel on this issue. The CR10 has the same fan shroud for the hot end, and it comes with a part cooling fan. So why not just make it like the CR10? I just took the fan shroud off. I'm going to mount one of these slim fans on the side of it, just like the CR10. I'm going to use some 2.5mm screws. I'm just going to drill and tap some holes. The stock ones are 2mm, I believe, but 2.5mm is the smallest tap I have, so everything should work just fine. Now that the holes are drilled and tapped, I'll just attach this duct that I found on Thingiverse to the bottom of this fan with 4 2.5mm by 10mm screws. The part fan and duct are on. Now I'm just going to grab some wire and make a quick pigtail so I can feed it back to the main board. Got the wires all set and put the plug on. Now we just need to add it to our main board. If you're going to add a part cooling fan to one of these boards, it goes in this port right here. It says K fan on it. So we'll plug it in just like that. So we've got new firmware and a part fan. That's going to help a lot. But now let's address a few issues with the bed. Now these bed plugs are always a sore point, and they're going to burn up eventually because they're not really made to handle this type of voltage. The best way to remediate this is to cut the plug off and just solder the wires direct. But what can also help is to add some strain relief. I found this part for strain relief for the Ender2 on Thingiverse, and I think it's going to work out great. It sets on here under the bed, and it actually attaches to the bed screws. So it goes underneath the bed leveling knob, and then it'll hold the plug, and you can zip tie the wires to it. And while we have the bed screws off installing the strain relief, I'm going to add these leveling knobs. These are going to make it a lot easier to level the bed, especially with one finger for that one that goes in the center. Now there's a lot of these available on Thingiverse, but none of them were a very easy print. So I remodeled these, and these seem to be working out well. So you just take off the existing leveling nuts and press them in the bottom of this knob, and then you can put it back on. Here's a look at the underside of the bed. Your strain relief is going to slide in right here, and it's going to sandwich right up against the heat plate. I am using PETG for all these parts, just in case they experience some heat, so it's a good idea to use ABS or PETG here. So I just slide it on over the screws, put my spring back on, and then you can install your cool new bed knob. These bed knobs are small enough to fit in all three locations. So my strain relief and all my knobs are on. We can just feed the wires down in here like this, and we'll zip tie the wires to this plastic part. This is going to do a lot to reduce the repetitive motion that these wires experience and lengthen their life. Sticking with working on the bed, no pun intended, I got a BuildTax sheet to go on top. So we'll clean this up a little bit. We'll get it lined up, and then we'll cut it to fit. That's close enough. And then we'll stick it on there. And there we go. Not too bad. Genuine BuildTax. I'm too good to you, Ender2. The next upgrade I'm going to make is to the Boden tube and the couplers. Now, I haven't had any issues with either of these on this machine, but I have on others just like it. These couplers aren't the greatest quality. And for just a few dollars, you can swap all those parts out. So you're going to need a 10mm coupler for the hot end side and a 6mm for the extruder side. I'm also going to swap out the Boden tube with some Capricorn XS tube. Now this is the lowest tolerance tube that they offer, but I had some, and I'm going to go ahead and swap it out while I have everything apart. It's also very useful if you have a flush cutter for these tubes, because you want these to be as flat as possible against the nozzle inside that hot end. So we'll go ahead and cut one end as flush as we can. I'm going to heat up the hot end to unstick any filament. We'll cut these zip ties, pull the tube out of the extruder side, and most of the time you're not going to be able to get the tube out of the hot end side because it does run all the way down. So I'm just going to back the coupler out. Coupler and tube are out. We'll take the extruder coupler off, put our new 6mm coupler on, put our new 10mm coupler on. I'll compare my new tube to the old tube that I pulled out, so I have roughly the same length of tube. Again, make sure both ends are nice and square. Use your flush cutter if you have one. I'll put this side down in the hot end. You need to push it down as far as it'll go. It needs to be as snug against that nozzle as possible. And you'll notice with this new coupler, you can't pull it back out. I'm going to bring the hot end carriage all the way over the right to the furthest position to try to judge how long the tube needs to be. And in this case, we were really close to the tube that I took off. So we'll make another flush cut on that end, and we'll slide it in on the extruder side. Nice and snug. So we're starting to look pretty good. We've made a lot of modifications to this machine that will probably help us out a lot with our prints. The bed knobs are going to help a lot with the fiddliness of the leveling. But what about this power supply that follows us around anywhere? Is there an easy way to attach it to this printer where it's a little easier to manage? I really had to look at this one, but I found one fix that might not be the best one, but it does work. Again, it might be a total hack job, but all I did was drill two 4mm holes in the side of the mainboard case, and I'm going to use two M3 screws by 8 to mount it to the side of the power supply. So the power supply will ride right next to the machine. Now it might have a hard time clearing the X, but we'll see in a second. So I'm just going to lean my mainboard cover up like this, line it up with the holes. I'll attach it with a couple of screws and washers. And then you should be able to just pick up the whole thing and set it back on there whenever you want to work on the stuff inside the mainboard. And it looks like the X carriage is just going to clear the top of the power supply. Now this fix probably won't last very long because this plastic isn't that sturdy, but I don't plan on moving it around much. I just want it out of the way. So this should work for me just fine. So we're doing pretty good. We've added some features that are going to make this printer a little easier to use and maybe get a little better print quality. But the biggest thing I don't like about the Ender2 is messing around with the bed level. So what would make that easier? How about auto bed leveling? Well, a lot of people are going to tell you there's not enough memory on this board to enable auto bed leveling. And there are some third-party products out there that you can flash to your main board to enable that scenario. But what fun is that? How about we get into Marlin and try to figure out how to get enough memory saved to enable auto bed leveling on this machine? Well, we'll get to that in a second, but the first thing we need to do is mount a bed leveling sensor. So I whipped up a quick leveling sensor mount that I can put right here on the fan shroud. It'll use the same two screws that the fan shroud mounts with. This is going to be a little tight for a 12mm sensor, but that's so that you can thread the sensor into this part. That'll give you a finer adjustment ability later. So I took off these two screws, and I'm going to mount my sensor where those go. I'm going to use two M3 by 10mm screws. And I'm going to start with my sensor about 1 millimeter away from the bed. We're going to use the zip tie trick. So you put your nozzle just touching the bed surface, and then slide a zip tie underneath your sensor, and then tighten it up. So here's what we're going to do for wiring for the sensor. We need to make a voltage divider, because we don't want to feed 12 volts straight into the main board. And we're going to power our sensor, since it's a 6 to 36 volt sensor, with 12 volts from the power supply. So the brown wire on my sensor, again this is an NPN, this will go straight on the main board to the 12 volt power supply. And then on the blue wire, I'm going to solder a 10K resistor. That's the ground wire. Then on the signal wire, that's the black one on my sensor, I'm going to solder a 15K resistor. Then on my ground lead with the 10K resistor, I will hook it to a lead that goes to ground to the main board and over to the other side of my 15K resistor that's on my signal wire. And then finally, on the end leg of my 15K, I'll put a lead that goes to the signal wire on the main board. I'll put some heat shrink on it and a DuPont connector to make it look all nice and neat, and this should work for our purpose. So to hook it up to the board, we'll remove the Z end stop wire. We'll hook the blue and black wire onto that connection. The front pin is the positive pin, so we'll put the signal wire there. That's the black wire. And the brown wire will hook directly to the 12 volt power supply, which is back here. I'm just going to stack it on top of the power wire. And there we go. The sensor's all hooked up. And even though your firmware is not configured yet, it should still trigger successfully. Okay, so all the physical modifications have been completed, and the bed leveling sensor has been mounted. Now we're going to get into Marlin, and we're going to shut off some of the features in the code to allow enough memory on the board for bilinear auto bed leveling. Now I'm going to show you a bunch of features that you can pick and choose which ones to turn off to allow us enough memory to do this. You don't have to do them all. You can do whatever combination you'd like, but these are just the ones that I found that have the most benefit. So we'll jump back into configuration.h, and the first thing I'm going to do is I'm going to enable bilinear bed leveling to show you what happens. So we'll start at Z probe options. Z minimum probe uses Z minimum end stop pin. That needs to be uncommented, so we're good there. We have a fixed mounted probe, so we'll uncomment that line. Our probe is roughly 40 millimeters to the left of the nozzle and 10 millimeters in front of the nozzle. After we calibrate, we'll come back and set the offset. Now we'll scroll down to the leveling section. We want to enable auto bed leveling bilinear. We'll go with the default of 3 points. The bed probe boundaries are probably a little too small or large for this machine, so let's go with 30, 150, 30, 150. We can adjust that later if we need to. We also want to come down and enable Z-safe homing. We'll uncomment that. This will home Z in the center of the bed because our probe can't reach the bed when it homes at the X and Y. So that should be good for now. Let's go ahead and verify. So we got an error about our probing position. That's because of the boundary limits. So let's make those a little smaller. Let's change the right probe to 120. And here's where we start seeing memory issues. We're 4,500 bytes over the limit. Now let's go through some of the features that I disable to get under this. The first one is show custom boot screen. You won't be able to see the boot screen, but it will save you some memory. Comment that out. The next one is prevent cold extrusion. This is what keeps you from being able to extrude filament when the hot end isn't heated up. Now I don't have a big problem with this, and it does save quite a bit of memory, so I'm going to comment that out. The nozzle park feature. Now M600 is nice for filament swap, but bed leveling is nicer. Go ahead and comment that out. It saves quite a bit of memory. Again, we're doing a lot of options and we're getting the maximum amount of memory possible. You might be able to mix and match features that you need. EEPROM settings. I'm going to comment out EEPROM. I don't like to use EEPROM commands anyway because it tends to make things confusing. Also disable M503. This is the command that will dump a whole bunch of information into the terminal about your printer. Unless you're debugging something, you really don't need it, and it saves a ton of memory. Let's jump to configuration_ADV. Baby stepping. Baby stepping is really nice to have to be able to adjust your first layer just right, but we have to make some sacrifices. So let's comment that out. And then finally, the advanced pause feature. If you're not using nozzle park, you really can't use advanced pause anyway, so we'll comment that out. Let's go ahead and re-verify. And we got it down to 89% of the board memory. Now, the lower you can go, probably the better off you are. As you start getting to the board memory limit, things start getting a little unpredictable. So again, mix and match your features if you want to, but I'm pretty happy with 89%. Now the upload's complete. The first thing we need to do is check and make sure that the sensor is triggering in the correct orientation. So let's head into Pronterface. Let's connect up. Let's do an M119 to check the in-stops. Now the probe is not triggered and it says it's triggered. That's a bad sign. So let's go ahead and trigger it and make sure that it is correctly triggering. We'll just use this pair of pliers, M119 again, and it's now open. So our logic of our sensor is inverted, but that's an easy fix. So we'll disconnect, head back into Marlin, we'll go up to the in-stop section, and we're going to set Z-min in-stop inverting to true. Also set Z-min probe in-stop inverting to true. If you don't set them both, you will get an error. And let's go ahead and re-upload. Our fresh upload's complete. Let's go ahead and reconnect with Pronterface. M119. Everything's open as it should be. Test it again with the pliers. Z-min is now triggered, so we should be good. Now the next thing I want to do is I want to heat the bed up to about 55°C, and I want to home all the axes. The Z probe homing is looking good. I'm going to take the Z height down to 0, G1, Z0. Now that the bed is up to temp, I'm going to turn all the motors off, and I'm going to run around the bed real quick and do a quick manual level, just to kind of get close. Okay, the manual level is pretty close. Hopefully that's the last time we ever have to do that. So let's G28, and let's G29. First time through, this leveling map looks actually a lot better than I thought it was going to. We can use a little bit of tweaking as far as our bed size goes, so let's go ahead and get back into the config and make some corrections. Let's change the left probing position to 20. That'll move it a little over to the left. The right was at 120. That one looked pretty good. The front, let's change that to 20. And the back, let's change that one to 140. I'm also going to comment out define minimum software in-stops so that we can set the offset for the Z. This will allow us to go into the negative closer to the bed. We can re-enable this after the offset is calibrated. And let's re-upload. Upload's complete. Let's head back into Pronterface. We'll connect back up. And let's home everything. Let's G29 again to see if our corrections look good. Okay, that looks better, but I think we can get a little closer in the front. So one more quick change. Let's change the front one to 10. And we'll re-upload. Upload's complete. Back to Pronterface. Connect up. Home. G29. That looks much better. Okay, that looks pretty good. I am going to make one more change to the left side, and I'm going to make that 10 instead of 20, but we can load that on the next upload. That's no big deal. Now let's move to setting the Z offset. So let's do G1, X 82.5, Y 82.5, and Z0. Since we have a 165mm bed square, that should get us to the center of the bed. Now we'll check the height of the nozzle with a piece of paper, and we're not quite close enough to the bed. So since we have Z minimum in-stops disabled, we can go into the negative. So we'll just lower the nozzle 1/10 of a millimeter at a time. So at 0.6 of a millimeter, it starts to grab the paper. So if you do M114, that'll tell you we're at negative 0.6. So that would be your Z offset. It grabs the paper at 0.6 just a little bit too well. I think I'll start at 0.55. So let's head back into Marlin, find your Z probe offsets, and we'll set Z to negative 0.55. We'll start there. And let's re-upload. Upload's complete. Head back into pronter face. Connect up. Let's home. Let's G29 again. I like the sensor position much better, and the grid looks pretty good. Let's get to the center of the bed. G1, X, 82.5, Y, 82.5, Z0. You check it with a piece of paper, and we have just about the right amount of drag. So at this point, we're pretty good. You can go ahead and re-enable minimum software instaps if you like. We might have to make a few tweaks later, but I think we'll be okay. Now let's get set up in Slicer. We'll do this vase model. Let's set it to vase mode. Let's go over to print settings. We'll start with the Ender2 configuration because that's what I already have ready. We'll switch the print height, the bed size. We can delete the Octoprint settings. We can leave pretty much all this the same because it's about the same setup as the Ender3. Custom G-code, we need to add a G29 so that it runs auto bed leveling each time we print. And in G-code, we'll just have it go to 150 when it's done. We'll save that as Ender2. Let's export the G-code over to the SD card. SD card's loaded up. Now let's start a print. And my upgrade path for this machine is complete. I did want to mention that I had to change up the back bed leveling knob to keep it from hitting the Y end stop, but all the links to the items that I used will be in the description below. Now, do you really need things like auto bed leveling on a machine this small? Probably not, but it does make the printing process a lot more consistent. You do have to give up a few things to enable enough memory to use auto bed leveling, but most of the time, I'm not going to use those features anyway. So it works for me, it might not work for you. I hope you found this video helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.